Okay, now let us take a look at challenging question. Okay, so you are given inequality which you are supposed to prove for all real x. Okay, so in other words, you are not required to solve this inequality. In other words, you are supposed to show that it holds for any particular value of x. Okay, so to do this, okay, first we will require a certain result. Okay, and that is if I have x raised to any positive integer power n. Okay, and then I subtract 1. Okay, this can always be factorized to x minus 1, okay, multiplied by this sum here, x to the power n minus 1 plus x to the power n minus 2 plus dot 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 plus x plus 1, okay, which is a geometric series here. Alright, now, so from here, the left hand side will actually be equals to x cubed minus 1 over 3, which is equals to 1/3 times x minus 1 x squared plus x plus 1. Okay, whereas the right hand side of the inequality is equals to x4 minus 1 over 4 equals 1/4 x minus 1 x cubed plus x squared plus x plus 1. Okay, so showing inequality 1 is true for any value of x. Okay, it's the same as showing that right hand side, okay, minus left hand side is greater or equals to 0 for any real value x. Okay, so what I'm going to do is I'll now substitute what I've obtained for the left hand side and right hand side respectively, okay, and see what I can obtain from there. So what I have now is 1/4 x minus 1 okay, so my new left hand side, okay, which is the right hand side of the original inequality minus the left hand side of the original inequality will be as follows. Okay, this is equals to, what I'll do now is factorizing. Okay, so I'll get x cubed over 4 plus x squared over 4 minus x squared over 3. So this would give me minus x squared over 12. Okay, so similarly I have minus x over 12, okay, minus 1 over 12. Okay, so what I'm going to do now is I'm going to take out the 1 over 12 to simplify my working a bit. Okay, so you realize that we actually have a cubic polynomial, okay, as part of the expression. Okay, now, so we try to factorize it, alright? Now remember, we want to solve inequalities, we always try to factorize our expression as far as possible. Okay, so to factorize the cubic polynomial, okay, note that x minus 1 is a factor of this cubic polynomial here, underlined in red. Okay, so I can factorize it further to x minus 1 multiplied by 3x squared plus 2x plus 1. Okay, how I obtain this is I can use this method here. Okay, I copy down the coefficients for each x power. Okay, since my factor is x minus 1, I put a 1 here. Okay, so I carry on the method as follows. I bring down the 3. Okay, now 3 multiplied by 1 is 3, so I put a 3 here. Negative 1 plus 3 is 2. Okay, so I repeat the step accordingly. Okay, and I make sure that okay, sorry, it should be a negative 1. Okay, I make sure that the final number here I should obtain is 0. Okay, and these three numbers, 3, 2 and 1 will form my coefficients of x squared, x and the constant term respectively. Okay, so this is what I get. Okay, so we actually have a constant, a positive constant 1 over 12 multiplied by a perfect square of x minus 1 times 3x squared plus 2x plus 1. So remember, our original goal is to show that right hand side minus left hand side is always greater or equal to 0. Okay, so this just leave us with trying to solve, okay, or trying to show that this part here is always greater or equal to 0. Okay, so we can simply do this by completing the square. So this will get 1 over 12 x minus 1 squared, okay, multiplied by 3 x, okay, x squared plus 2/3 x. Okay, so now I would have the following. Okay, and this should simplify out to okay, so indeed, once we have completed the square, you realize that the quadratic expression, okay, the remaining quadratic expression is always expressed as a perfect square, okay, times a positive constant plus another positive constant. So this part here is greater than 0 for any real value of x. Okay, so we can finally conclude that this expression must be greater or equal to 0, okay, for all x in R. Okay, although we have 3 greater in this part of the quadratic expression, okay, the final conclusion can only be, we can only go to as far as to saying that it's greater or equal to 0, because x minus 1 squared can still be 0. This part here can be equal to 0. Okay, and it happens when x equals to 1. Okay, and so we have proven what we are required to show for our original question, which is to show that, alright, x cubed minus 1 over 3 is less or equals to x4 minus 1 over 4.